Now let me explain you how to conduct principal component analysis using SAS. And in this, we are not just going to learn the SAS syntax, we will also understand a fair bit of detail of principal component analysis itself by analyzing the output. So let me just show you, this is the syntax, and let me show you how does it look like on the screen. I am using the academic version, and here for this purpose I am using this particular data set. So this data set I have got from some site, and this data set has about a survey result that from the 16 participants, and what do they value when they are trying to buy a new computer. So do they value price, software, aesthetic, brand, their family members, and I have added just a variable here which is just some formula I have put it and tried to put it here, so and randomize thing, so I have put it new variable here. And the whole idea is that I will take this data, work step by step, and show you how to conduct PCA using this data. So you have this data. The first thing I have done little bit of treatment. So what I have done here, if you look at everywhere, you have maximum rank to 7. That's what it says, that 7 is strongly agree. So again using the formula that I have talked, rank minus 1 by max rank minus 1, because max rank minus 1 is everywhere 6. So I've divided everywhere by 6, and I created that 0 to 1 variant that I showed you, that how to convert an ordinal variable into 0 to 1 scale. And I have taken this variable just like that. Now I have saved this data as CSV, and I'm going to use that in SAS. So I have the CSV file here. Let me just read that data here. Let me try to bring it in between so that I can show you maximum portion. So here is the data, the same code that you are seeing in PPT. I am running it. It looks like probably I have moved the data, and that's the reason it is giving me the result. Let me pause the video and correct the code. So in this code actually I had moved the my PCA program under a folder called statistical stuff. That's what was giving error. So I'm just going to load that data very much the same way you do it. Let me just bring it in between so that everything comes in between. So let me just read that data. This term str option that you see at the last, that is all about to let it know that the file has got generated in Windows, and I'm using it on Unix, so it should take care. So let me read this data and import this data in SAS. Again it has given error. I mean, looks like I have not selected properly. Let me just do once again. What is it doing? So the data was already there, and that's why it was throwing error. So I just put a replace option here. Now let me try to get the data once again. It has got the data. It is giving you the output. You can see all the variables has come properly. Now let's go ahead and use the principal component. So it produces several of the output like mean, correlation matrix, eigenvalue, eigenvector detail, and the scree plot. I have already downloaded this in machine, and I'm going to show you in the PPT where I'm going to explain each and every part that you are seeing on screen here. Every part that you are seeing on this screen, so that I don't need to do to and fro, and I can directly show you on the screen itself that how it is coming. One more thing you need to understand, that like if you standardize data in SAS and take a look, the standardized output is very much same as what output you were getting earlier. Here I have standardized, and I'm running it on base 1, which is the standardized data. and you will find that this output is exactly same as what you were getting earlier. The only difference that you will see that is in the mean and standard deviation, rest everything is coming same. So because SAS is robust enough to take care of the standardization on its own, so it doesn't matter that you standardize or not, it will still produce the correct result. Also it proves that intrinsically SAS is working on standardized data only. Now I have downloaded the output and I am going to explain you each and every part of the output. So the first part of the output is that it produces the data and the simple stat. So it is saying there are 16 observations and 7 variables. Also one thing you need to understand, if the data has missing values, missing rows, it ignores. Like in this, actually there were 17 rows when I run it. Let me just show it to you. If I open the data set, this data set, you'll find there are 17 rows were there, and it is ignoring the last one because last row was just the blank. You take a look, see last row was blank. So SAS ignores the missing values, and you observe the difference in the scale. These are when we converted to 0 to 1 scale, as you are seeing. Let me just run it once again so that time to time I can show it to you. So then when you are running this, so these are standardized values, scaled values when we converted to 0 to 1, but this is like very much the raw value that you are seeing. So obviously this has a much larger scale than this, but as I told you, SAS intrinsically takes the only standardized value. It further standardizes even these variables and this one. Now it produces the correlation matrix. The correlation matrix that you are seeing, here it produces the correlation matrix. Now if I ask you what it is it R or R square? Think of. It has to be R because it is negative and positive both. R square is not negative. Second thing, if I ask you does 0.63, which is here, minus 0.63, represents higher strength than 0.61, which is you will see somewhere 0.61. Does it represent this one is a family and friend has a stronger relationship, or aesthetics and price? The answer is actually aesthetics and price. Why? Because negative and positive is just giving you the direction. The magnitude, higher the magnitude, absolute magnitude, that's what is the strength of relationship. Which variable income has the closest relationship? So if you look at here, it is 0.988. So obviously the way I have derived it, I would have used price and then multiplied it by somehow to generate this income variable as random variable, because I would have taken some error component. Now let's understand what it is doing here. Here it is giving you first the eigenvalue. So there are 7 eigenvalues. Why there are 7 eigenvalues? Think of, because there were 7 variables, so you'll get 7 eigenvalue. Remember, and inputs and eigenvalues and principal component. This is your first principal component, this is your second principal component, like that. And this is the first eigenvalue or the variance of the data in the direction of first principal component. This is the variance of the data in the direction of second principal component. Now if you think of, if you would have 5 variable, how many you would have got here? You would have got 5, because as many eigenvectors, as many principal components, as many input variables. And why this average is coming 1? Because if you think of, SAS is intrinsically taking the standardized variable. The moment you standardize any variable, the variance is 1. You remember that I showed you when you take x minus x mean by x standard deviation, the standard deviation was coming 1, and so variance, because variance is nothing but the square of the standard deviation. So if there are 7 variables, the total variance is 7, and if there are 7 input variables, the average has to be 1. If there were 5, again the total would have been 5, and 5 divided by 5 average you would have got 1. You can take this data, take 5 variable and try again, you'll get average 1. Now the first eigenvalue is this one, and obviously it is biggest one. If you take a look, it is obviously going down. Every first eigenvalue is bigger than second is bigger than third one. Now this is what is difference here. The maximum value here is 3.13 and the lowest is this one. The second eigenvalue is 1.70. Look at the graph, it is going down, that's how it happens. Now what is difference? Difference means how much it is changing from first to second. So from 3.13 to 1.70 it is reducing by 1.43. From 1.70 to 0.93 it is reducing by 0.77. What is proportion? If you think of the total variance is 7, 3.13 divided by 7 gives you this proportion. That's just this component is explaining. This is explaining 44% of the total variance. This component is explaining 24% of the total variance. If you think of 1.7 into 4, it will become 6.8, and that's why, and total variance is 7, and that's what it is showing. So 7 divided by 1.7 will give you 0.2434. Now what is cumulative? Cumulative is nothing but the sum of these. Like this is 0.43 and this is 0.43 plus 0.4483 plus 2434. That's what it gives you here. Now this is like, what is cumulative here? 6917 plus 1330 gives you this one. So proportion is the variance of the total variance that get explained by the principal component, and cumulative is obviously the total cumulative proportion that is getting explained. Now how will you know how many principal component you should keep? So one rule of thumb, which is called Keizer criteria, is that you keep only the variable which has eigenvalue greater than 1. That way you will keep only these two, and that will explain the 69% of the total variance. Think of, if you were taking just 2, probably you would have explained roughly around 25% of the total variance, but because the eigenvectors are getting constructed in such a way that the first eigenvalue is biggest, then the next one, and that's why just 2 of them are able to explain 70%, roughly 70% of the total variance. But one thing you need to keep in mind, that you don't need to take it without thinking, mindlessly. What about if there is one eigenvalue which is 1.001 and the second is 0.999? Obviously there is no point that you will keep one and you will not keep this one. Also you can look at the proportion of variance accounted, add the scree plot. Scree plot actually helps you, and if you get a L-shaped curve, it is essentially the point where you get elbow of the L. So here you are getting the elbow of the L if it was like just this shape, and then you will take everything before you are getting the elbow point. So take components prior to getting elbow point of the L shape. However, this also gets into trouble if there is no clear L shape, or if there are two L. All said and done, there is no hard and fast way of doing this. You actually apply your common sense and take it, but on an average you can say that take all those which are coming before the elbow curve, or take only those which are more than eigenvalue 1. So that way these two, or if at all you decide to go a little further, you will keep another these two. Let's take that how the factors are getting derived. The last part of the output that you see, is this how the factors are getting derived. So it is all about that, this first principal component is coming as 0.5517 into price plus 0.1308 into software, like that. One thing you need to understand, that everywhere it is taking the standardized variable, not the raw variable. That's how you conduct analysis principal component analysis in SAS and you interpret the output, you decide how many principal component you want to keep and you understand how these principal components are getting derived. Now I will show you the same thing using R.